are you interested in? Again, maximizing volume. So I like to maximize the volume or a surface area or something like that for you to see. Maximizing profit, if you'd like to go back to that. Minimizing surface area. Let's start with that. Minimizing surface area, problem 48 on page 257. So let's read the problem. A closed top cylindrical container, okay? Closed top cylindrical container, that's all I know so far, is to have a volume of 200, I found an error. It says volume of 250 squared inch. On page 257. Is that correct? Is the volume measured in squared inches? Very good. Okay, so that cross that out and change it to cubic. What dimensions, radius and height, find the radius and find the height that will minimize the surface area for a min area. So we are given a container that is like a can, right? Like a soda can. So here it is. Imagine that it has the bottom and the top. Okay. So how will I determine, because the key word here is area. Okay. So first of all, it has a bottom that is, what is the area of a circle? Pi r squared. Very good. Pi r squared plus pi r squared. But now I have to determine this surface area. Here it is. Ready? So what is this? So it's the area. What is the length of the base? Remember where it's coming from.
So the circumference of the circle.
Exactly. 2 pi r times the
Height.
exactly. Excellent. So obviously that's my starting point, because I need to minimize the area. So one more time, can anyone tell us what to write? Of course, I'm going to denote this by r, and I'm going to denote this by h. So the surface area for the can, or whatever container this is, will equal 2 pi r squared, 1 and 2, excellent, plus, one more time, the width of the base, 2 pi r, times the height, which is h. Very good, awesome. This is what I'm trying to minimize. However, how many variables you see here? You're correct. If you want to say that this is a variable, I completely agree. That's the function, but you're right. So r is a variable and h is a variable. At this point, we don't know how to handle a function with two variables. So somehow I have to make one disappear. Yes, I have the way, because I'm given a piece of information. So now let's find the formula, or remember the formula for the volume of this. So this is like the volume of air in this room. Area of the base times the height. So the volume will be area of the base, pi r squared times the height. From here, I have pi r squared times the height equals 250, because this is given to us. What do you think I'm going to solve this equation for and plug it in the surface function and make the surface function of one variable only?
Solve for h.
Right, but I don't want to solve for r, because I have to take the square root. And I don't want to do that. Very good. So from here, I'm going to solve for h, and this is 250 over pi r squared. And now I can say that s is only a function of r once I replace h by this. So then I have 2 pi r squared plus 2 pi r multiplied by 250 over pi r squared. I'm going to simplify a little bit, but I can't simplify a lot. The pi will go away, and 1 r will go away. So then I have 2 pi r squared plus 500 over r. This is s of r. Okay, so let's not lose track of what we're doing. So we determine the function that we need to find the minimum for. We obtain the function after some algebra. We obtain the function with only one variable, because that's what I know so far. I have the function. I want to find its minimum. What would be my next step? Exactly. Find the derivative. Awesome. Thank you, Angel. Well done. So S prime. See how useful that formula is that I just mentioned to you. So this is 4 pi r minus 500 over r squared. You don't have to mess around with changing this into an r to negative 1, because we already know that the derivative of 1 over r would be negative 1 over r squared.
Is it squared or?
Negative 1 over r. Yes. Yeah. Let's look back. Very important. Very important. Please remember this. Extremely important. So we don't have to reinvent the wheel. Otherwise, you would have to change this into x to negative 1, bring the power in front, subtract 1 from the power, and change it into a fraction. So why reinvent the wheel? It's not that difficult, but you can use the formula. Very good. So comment, yes?
So where did the 4 come from again? Is that the derivative of?
2 times the exponent of 2.
Remember what we just discussed? I bring the power in front, multiply by 2, and that's how I get the 4 pi.
2 times the exponent of.
And then I subtract 1 from the power. You remember that?
Yeah.
Okay, perfect. Good. Excellent. I have the function, I have the derivative. Now what?
You do equal 0.
Exactly. Because critical numbers will not come from this being undefined. The radius cannot be 0. There is no volume, right, of the can if the radius is 0. That's not possible. So only S prime equals 0 can give us critical numbers. But remember, we have to find the least common denominator. So this is 4 pi r cubed minus 500. So the least common denominator is r squared. I have to multiply that by r squared. So that's how I get 4 pi r cubed minus 500. When is the fraction 0? Well, when the numerator is 0. So I said 4 pi r cubed minus 500 said equal to 0. R cubed equals 500 over 4 pi. Of course, what will I do to both sides to find r? Exactly. Excellent. Perfect. So I cannot add or subtract fractions that don't have the same denominator.
So that's
So-
like over 1.
Yes. So this is like it's over 1, so you have to multiply it by r squared. Better? Perfect. So now I have r. I have s of r. And I have 0 to infinity if you want. And this is the cube root of 500 divided by 4 pi. And this is, of course, in inches. And this is s prime, which is 0. And this is s of r. In case we're asked, I don't even remember if we are, it says what dimensions minimize the surface area. They're not asking us to find the minimum surface area. But I claim that this gives a minimum. And you should say, show me. You just determine the critical number. It's beautiful. You say that the derivative is 0, but you haven't shown that this gives a minimum or a maximum. Okay, so then, what do I have to do?
Number on either side.
Yes, excellent. So this is the derivative. Will I plug anything in the denominator? So let me also write it here. 4 pi r cubed minus 500 over r squared. Will you plug in anything in the denominator? No, because it will be a waste of time. It's r squared. A positive quantity will never change anything. Don't waste your time with this one. But here it's a different story. So when I plug in 0, you can say you can't. True, but I'm just plugging 0 to find the sign. When I plug in 0, not in the denominator, of course. When I plug in 0 in the numerator, what is the sign? That's it. Good. When I plug in, I have to estimate roughly what this is, right? But you really don't need to. If you plug in 1,000, it's definitely more than -5. So this part, it will be positive for sure. So this function s of the cube root of 500 divided by 4 pi will definitely give what type of what point?
Critical?
Yes, but now I know it's more than critical because I studied the sign of the derivative. I see it changes sign in this specific negative, 0, positive.
You have to do the double derivative to see if it's maximum.
No, I already know. Now, if it's easier for you, if you remember, that's a second derivative test. It's a very good question. If you don't want to find the signs, you don't want to bother with negative and positive, then take another 10 minutes and find the second derivative. And plug this beautiful number in it to see if it's positive or negative. But yes, for some functions it works better than for others. Well done, very good question. Now, we have not finished because we are asked to find both the radius and the height. So we found the radius that gives a minimum surface, which is this. But now they're also asking us to find this. Not a problem. I have the formula because I solved for h initially. So this will be 250 divided by pi, and then I have to square this. So it's the cube root of 500 over 4 pi squared. At this point, I will put these numbers in the graphing calculator and give an approximation. Because if I tell you I have in my pocket the cube root of 500 squared over 4 pi dollars, what would you say? What does that mean? So let's put in the graphing calculator and determine these values. So the first one was the cube root. So I'll put in parentheses that, but that's me. You can use other features of the calculator. Divided by 4 and further divided by pi, or you put the parentheses you want. And I like to raise this to power 1 over 3. That's what works for me, and that's the easiest for me. Remember, you either put parentheses around 4 times pi, or you say, I divide 500 by 4, and then at the end, I divide again by pi. Be very careful how you put it in. So, but you have more sophisticated calculators, so you can put in the expression as is. I know that. So this is 3.41 inches, approximately 3.41 inches. And then I will have 250 divided by pi and further divided by the previous answer squared. I don't want to put that in again because that's what we have. So we do have everything but squared in the denominator. So I tell the calculator to divide 250 by pi and by this number, whatever that is. I'm not going to truncate that.
So what are we doing right now?
Finding the height and the radius that give the minimum surface area.
When I put in this 500 divided by 4, divided by pi, I'm getting an error.
I got 7.3.
Let's take a look. We had discrepancies before, so it doesn't mean that you made an error. Because you put the a brace instead of a parenthesis.
Okay.
Oh, it's divided by 5.
You forgot to put 1/3 in parentheses. Powers have to be in parentheses, be careful. Powers in parentheses. Did anyone else get this? Did anyone else get this? Awesome. Good. Yes, Maddie?
Sorry, did I write that right? Oh, what was on your calculator? So 500 divided by 4 divided by 5.
Yes,
Yeah.
or you put 500 divided by 4 times pi in parentheses. So then the calculator divides by both. Either one.
And
Yes?
where it says answer.
Yes, the previous answer is all this calculation.
Mm-hmm. And you plug that into what, 250?
So no, I have the second and answer. Second and answer right here.
No, I mean, that function, whatever, that was the original. Where's the 250 divided by pi? Where did that come from?
This. It's the h, the height.
Oh, yeah.
So this quantity is this squared. So 250 over pi times r squared. Any questions? Is this okay? Any questions? Okay, moving on. You can come back to any problems you would like, or if you find anything in my math lab, please bring all your word problems back to class. And of course, we're going to do more. But I'd like to move on to 2.6, marginals and differentials. Marginals and differentials. I would like to look at a graph. So we can explain what is this, what it means. So let's look at this graph. So here's a function. Here's a point. I'm going to call it P, of course, of coordinates x. What will be the y coordinate of P? F of x, good. And let's say there is an error. Or if you want to call it a change of delta x and dx. This is dx and this is delta x. Tiny change in x, but I'd like to zoom in. So I'm going to say this is x plus delta x or x plus dx. This is obviously what?
X plus
Just the delta x, right? Delta x or dx. Of course, like before, we're going to call this point Q. Coordinates x plus dx. And can anyone give us the y coordinate of Q? The y coordinate of Q must be f of x plus delta x, also the same thing, f of x plus dx. They are the same because delta x and dx are the same. bear with me and draw a horizontal line right here through P. And then I'm going to ask you to calculate this distance for us. Anyone? This distance is delta y, the exact error or difference in y triggered or created by
Delta X.
awesome, delta x equal dx. Indeed, that is what happens whenever I have a minor change in x or a change in x. It would trigger automatic change in y value. Okay, perfect. And this is, I stress the word exact. So then the formula for delta y, which is the exact difference in y triggered by a change in x, is, can anyone give us the formula? Excellent. This minus this. So f of x plus dx minus f of x. Indeed. This is the first formula we need here. Great job. Perfect. Now I would like you as the next step to draw the tangent at P. Extend the tangent at P till it crosses the vertical through Q. You understand that all this is absolutely huge. This Q is right here. So the difference in y values is tiny. I made it huge so I can explain. You understand that this tangent, because Q is right here, the tangent will not be so far out above Q, because Q is here, right? Good. Stay with me, please. Now, I would like us to look at this triangle. And now I would like to, by chance, it's just crossed that line, so I don't want you to get confused. I would like now to discuss this difference. So because I have already so many different things in there, I'm going to take that aside. So then we have this. This is Q, this is P, this is, I don't know, A, if you want. This is indeed dx, or delta x. This will have a name in a moment. And I would like you to tell me the slope of this line. So give me the slope of the line going through P. Let's go back to the original graph. I want to determine the slope of this line, which is the tangent line to the graph of f of x at P. There is a function that we discussed already for a few weeks that will give us the slope of that line at P. Which function will give us the slope of the tangent line at a point? Point slope. Which function? That would be the equation of the line, but I want the slope of that line. And there is one function that will give us the slope of the line at any point. The derivative. Right? So can anyone now, knowing that f prime at this point is nothing else but the slope of the tangent line, right? So if this is 5, f prime of 5 would be the slope of this line. If this is 3, then f prime of 3 would be the slope of that line. Is that clear? Very good. So then, this is f prime of x. Y of x, because this is x. If this were a 5, I would have written f prime of 5. Okay. Now forget about this for a moment, and please give me the slope of the line PA. Its rise, whatever it is, over run, whatever it is. But you already told me that this equals what? Good. So now look at this equation. Oh, look at that. Look what I did. I'm going to have to write it again. Rise over dx equals f prime of x. So disregard this one. So now look at this equation. Think hard and say, I know the rise must be, and there is only one thing that fits in here. dy. There is nothing else. F prime is dy over dx. There is nothing else. So then this is indeed dy. This is indeed dy. What is its name?
What do you mean with that?
Because these are the two notations we've been using interchangeably. We know that f prime of x is the same with dy over dx. So now solve this equation for me for dy. Let me give you a hint. Yes, we just write it like this. So what does this represent? Is the differential of y. So wait a minute. We have to identify and I understand what this means. So the actual distance or error or change in y created by dx is delta y. But then what is this? What does this mean? What is the explanation or meaning of this? So coming back to our original graph, this is dy. Now, before I explain what it means, imagine please that q is very, very close. So then this actual distance will be this, and dy will be this. I cannot even show you. What do you think will be the relationship between delta y and dy? And I'll tell you what dy represents in a minute. If you imagine that q is extremely close to p, what do you think the relationship between the actual distance or actual difference and dy will be? Say it again. So give me a relationship between delta y and dy. Keeping in mind that q is very, very close to p. Absolutely. Well, I cannot really use the equal symbol though. So I'm going to say this. They must be very close. They must be very close. Of course, they are close. The closest q is to p, the closer they are, right? If they're at 1 unit distance, maybe that's not, depending on the function, maybe there is more difference between the two. But they should be pretty close. Now, let's see what this means. This is not the exact difference. We understand that it's not the exact difference, right? Because we did not use f of x plus dx minus f of x. So delta dy is the change in y for a minor change in x, but not using exact. It's not the exact. Is obtained using the derivative. That's why it's not called the exact difference, but it's the differential. It uses the derivative to find the difference. So this is not the exact. So this is the differential of y, which means the difference or change in y created or triggered by what? By dx, indeed, by a change in x. Not using the function values, but using f prime of x. Exactly. That's why this is not the exact difference, but it's an approximation. Question, what would be the use of it? Why would I even bother with this if I can find the difference? It's kind of hard to find the exact difference. This will be a very elegant way of finding the difference and way easier. That's why we want to know the approximation. When we're asked find the exact, then I have to use this. If I'm told approximate, estimate, I'm going to use this. Ready for a problem? To see how this works? Any questions? Okay, let's start with number 6 on page 266. Let's read the problem. The weekly profit in dollars from selling X cars is given to us. So this is profit weekly. Please remember, every time you read a word problem, always take notes. Take notes on the measurement unit, take notes on whatever else is needed. So P of X, negative 0.006 x cubed minus 0.2 x squared plus 900x and minus 1200. Let's read on. And currently 60 cars are sold weekly. 60 cars sold per week. Okay. Part A. What is the current weekly profit? What is the current weekly profit? What do I have to do? Plug in 60, correct? Very good. So P of 60 is negative 0.006 times 60 to the third minus 0.2 times 60 squared plus 900 times 60 minus 1200. If you have this number, give it to me. Don't torture me. If not,
50,784.
okay. If you all agree, what is it? 50,000. You said
184.
Okay. So this is part A. Let's read part B. How much profit would be lost if the dealership were able to sell only 59 cars weekly? What do I have to find? Let's come back to our beautiful function. So now this is my 60, and dx is not positive, but it's on this side. So this will be 60 and this will be 59, and delta x or dx will be negative 1. Right? Good. So then I have to find P of 59. Just replace 60 with 59 all the way. How much is that?
49,971.
And the delta P is the exact difference. And that will be P of 60 minus P of 59. From our graph, I will go back several times. It's this, where this is 59 plus 1 and this is 59. So P of 60 minus P of 59. And we got 50,784 minus 49,971, and the difference will be 813. Okay, very good. Perfect. Next question, part C. What is the marginal profit? Okay, we have to talk about marginal profit. Marginal profit is nothing else but the rate of change of profit. And we had X, yes. This is the marginal profit. So let's find P prime. Here's the function. Negative 0.018 x squared minus 0.4 x plus 900. Part D. Use marginal profit to estimate the weekly profit if sales increase to 61 cars weekly. Before we even read part D one more time, and we're asked to find what is the marginal profit when x is 60, forgive me. So P prime of 60 is negative 0.018 times 60 squared minus 0.4 times 60 plus 900. If you have this number, please give it to me. And then part D. Perfect. Perfect. Okay. Before we even talk about use marginal profit to estimate the weekly blah, 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 I want to come back to our expressions. We know what delta y means. It's the exact change in the y in the function for a change in the x. Okay. And we established that this is approximately not equal, but quite close to the differential of y, which is dy. Correct? Good. So now let's write the left-hand side and the right-hand side, because this is one of the most important topics in this section, or chapter even. Again, how do I express delta y? In general, using f of x, and then we'll change it into p. It's f of x plus dx minus f of x, excellent. And now, sorry. The right-hand side, the definition of the differential of y. F prime of x times, excellent. I would like to solve this. I don't even want to call it equation because it's not an equation. It's not an inequality. Whatever. I want to solve it for f of x plus dx. I will move f of x to the other side. So this is approximately f of x plus f prime of x dx. Question. Before we answer what they want us to answer, I want to answer one more question. The question is saying use marginal profit to estimate the weekly profit if sales increase to 61 cars weekly. Perfect. So what does X represent in this super important relationship? So remember, we are talking about 61 cars. So what does X represent here? The change is exactly 1. So what does X represent? Exactly. What does the minor change represent?
1.
Exactly. What does this represent? Well, f of x in our case is going to be p of 60. What does this represent? Well, in our case will be p prime of 60. And what does this again represent?
1.
Exactly. So let me erase this 61 because it appears that it is somewhat connected here and I don't want it in there. Exactly. So now we can answer the question. Use marginal profit to estimate the weekly, which is this. This is the marginal profit. To estimate the weekly profit if sales increase to 61 cars. this will be what I'm looking for. So now here I can write the equal symbol. I have P of 60, we calculated a long time ago, 50,784 plus. I have P prime of 60, we calculated 811.2. And I do have the minor change, which is 1. Now you understand that this relationship will not be the best to use if I increase the sales from 60 to 100. It will not be good to use from 60 to even 70. But if I have a tiny change in X, this relationship will give us a very close, very good approximation of the actual profit. But if the tiny X is 10 or 15 or 20, the relationship will not work. The error will be big. There is an error here, but not big. So this is the answer.
51,590.
Say it again.
Oh, 51,595.2.
Very good. Any questions? Okay, I think we should work on another. Yes, please.
This is about the use of this in concept. So, like, if for whatever reason your employment required this, you would have to declare whatever you're declaring with that, and then state the error, right? Meaning how accurate your work is.
Yes, you could. And in some situations, we will get percentages, like percentage error.
Okay, but will we be calculating that?
Yes, let's look at a problem like that. Of course, absolutely. Let's look and see if there is a.
Second,
I do have. I can show you problems from the other book for calculus 1. I don't know if they are in here, but we'll look for it. Yes.
real quick,
Yes.
the dx, that's 1 every time?
Because no, it can be 0.1. It can be 0.2. But if it's 10, I have doubts that this is a good approximation.
It's because you just didn't see the marginal profit for 60 cars, and then indeed they're asking